Hello everyone, welcome in this channel Mausam Science. Today we are going to learn about the famous laws of electromagnetism, that is a Lenz law. Okay, right now I am preparing a video regarding magnetism. Before this, some videos regarding electricity was already uploaded in my channel. If you wish, then you can visit that video. I'll give the link in description and upper I button. Today we are going to know about the Lenz law. What type of law is called the Lenz law? Okay, it is the very important law of magnetism. For that we need to understand these 2 points. The first one is change in magnetic flux induce electric current. As I told you already in my video, okay, if you are following continuously in my video, then you know that magnet have 2 poles, north and south pole. The magnetic lines start from north pole and ends in south pole. Okay, this creates a magnetic lines. Okay. Now, if this is a current carrying conductor, if I keep it here, then the number of magnetic lines which pass through this current carrying conductor is same. Okay, now it is same. After 2 seconds also it will be same. But if I move this conductor, okay, then what happens? The number of magnetic lines which passes through this conductor will be different. So as a result, there is a change in magnetic flux which induce an electric current in this conductor. Okay, before there was no any current, so there will be the induced electric current. If the word is induced there, it means it will be created. Before it was not there. Okay, later on the direction. Okay, the next point I am going to read out, okay, and justify this. Direction of induced current is such that it cancels the initial magnetic flux. Now the current will be induced if either conductor moves or a magnet moves. There is a change in magnetic flux, and what happens? Current will be induced. Now in which direction the current will be induced? Either in forward or backward. Okay, it will be induced in such a direction that the magnetic lines of force is coming from, suppose let us say the direction east to west. Okay, east, west, north, south. The direction is from east to west. Now the current will be produced in this conductor in such a way that if a current is produced, then it can create a magnetic field. Okay, its own magnetic field. I repeat once, electricity and magnetism are interrelated with each other. If there is magnetism, we can create a electricity in this conductor. If a electricity will be created in this conductor, then it can create its own magnetic field. Okay, like this. Now the magnetic field will be in such a way that it tries to cancel out which magnetic field is producing the current in it. That means the magnetic field which will be produced in this current carrying conductor will be from the direction west to east. Okay, let us understand this with a simple experiment. I have made here the magnetic lines of force from down to up. Okay, these lines, let us imagine it is coming from down to up like this in a copy. If I keep here a current carrying conductor, okay, suppose I don't mean a current carrying conductor. I told already, I will keep a conductor over here moving. Okay, a conductor is moving. This conductor is in square shape. Okay, it is moving over there. Now what happens? The current will be induced in this conductor. Now in which direction the current will be induced? Let us suppose if the current will be in the forward direction. Okay, this direction the current will be induced. Or if the current will be induced in the backward direction. Now we will talk about the forward direction at first. Now what happens? If the current is induced in forward direction, then we need to take a right hand thumb rule. Okay, suppose if the current is in forward direction, we will take a right hand thumb rule. This thumb indicates the direction of current, and this finger will give the direction of magnetic lines. Suppose the current is in upward direction, this one case, okay, this case we are talking the upward direction. Then what happens? The current, if the current flows in upward direction, then this gives the magnetic lines of force. The magnetic lines of force will go like this, okay, like this. It will come and it will go down. It will come and it will go down in the direction of this finger. Okay, suppose it is coming from here, going down, and again coming and going down. Okay, that means it is increasing. Okay, the magnetic lines, the magnetic flux which is produced due to this direction of current supports this more magnetic flux to be there. Okay, why? Because the magnetic flux is coming from down to up before, and as a result, if the current is induced in this conductor, then it has its own magnetic flux which increase this number of magnetic flux. Now what happens if it increase? If it increase the number of magnetic flux, then what happens? The before magnet will be more powerful and more current will be there. Again, if more current will be there, it creates more magnetic flux in the same direction. Then what happens? More flux, more current, more flux, more current. It is impossible because energy is always conserved quantity. We cannot create more energy. Okay. So as a result, the current direction will not be in forward direction because it tries to cancel out, but it is supporting. Okay. Now let us talk the direction of current. It may be downward direction. Okay, maybe. Now what happens? You will take the thumb finger down, okay, of your right hand. Then what happens? This gives the magnetic lines. This finger gives the direction of magnetic line. Now what happens? Before the magnetic lines was from down to up. Now my finger is going from up to down. That means it is trying to cancel out rather than supporting. It is trying to cancel out the magnetic flux which helps to produce the electric current. Okay, I repeat once, it is very interesting. Whatever the magnetic flux is induced, okay, whatever the magnetic flux was there before, it helps to induce a current in this conductor. Now the current direction will be in such a way that it tries to cancel out the direction of this. So as a definition of this Lenz law, the current direction will be applicable for the downward direction. In this case, you can easily notice, okay, if the magnetic lines of flux will be in downward direction, the case will be opposite. The current direction will be upward. Let us see. Before there was the magnetic flux rather than upward, it was downward. When I keep the finger, okay, right hand in the direction of this current induced, okay, I suppose the current will be in upward direction. Then what happens? This finger cancels out this upper one, okay, this lower one, because this finger is coming up. That means the magnetic lines of force which is created by this current, okay, induced in this part of coil helps to cancel out according to the Lenz law. So this current direction is there, okay, it is the correct current direction, and this one, the upper one is incorrect, down one is correct. So as a result, with the help of this Lenz law, we are going to find out the direction of current induced due to the change in magnetic flux. The direction will be chosen in such a way that it tries to cancel out the initial magnetic field which produced the current. It is very interesting. I hope you know this video. Please write in the comment section. We'll meet again. Bye-bye.